Hey guys, welcome. So in the last video we have discussed how any material behave under a mutually perpendicular to stress, whether it is tensile or compressive. Okay, and we have also learned how to calculate the strain when this type of stressors are acting on your body. And in this video we learn what will happen if a pure shear stress means there is only shear stress like this. There is no normal stress. Okay, there is no normal stress. So how a material behave during this type of stressed condition? Okay, so let's start. Let consider this object. Let's say here you have applied tensile stress along your x-axis. This is x, this is y, and let's say this is sigma x, and along y-axis you have applied compressive load or compressive stress, that is your sigma y. Okay, and now sigma x and sigma y, they are numerically equal. Okay, or you can say sigma x is equal to minus of sigma y, because sigma y is compressive in nature. Now if I ask you to find the stresses in any plane, let's say this one, what will you do? Simply you will draw the Mohr circle or the stress circle, and in stress circle this is your normal stress, this is your shear stress, these are positive, this is positive, this is negative, and this is negative. So let first plot this sigma x. Let's say this is this one, sigma x, and let's say this is point A. And what about this sigma y? As this is negative, so you have to plot here. Okay, and this is sigma y, or let's say this is B. And next step is you have to draw a circle considering AB as your diameter and as this origin as your center. So let's draw it. It's let me draw it properly. It will look like this. Okay, and at this point, if I ask you, let's say this is point D. If I ask you what is the shear stress corresponding to this, obviously this is nothing but radius, and this radius is your sigma x or minus of sigma y. Okay, so this shear stress tau is equal to this one. And what is the normal stress here? Obviously 0. So normal stress is 0. And if I ask you to find the plane in actual body, obviously you can do this. How? You have to simply draw the plane. How? You know that, let's say this was original plane, and you have got this plane by rotating the radius anti-clockwise for pi by 2d to rotation, and in actual case it will be pi by 4. Okay, so this is the plane where your shear stress is sigma x or minus of sigma y, and normal stress sigma n is 0. Simply in this plane also this is same, there is no normal stress, sigma n is 0. Like that you can find that in this material or in this body, in all of these 4 plane, there is no normal stress. Okay, normal stress is 0. And when this is happen, or when in any plane your normal stress is 0 and only shear stress exists, we call the state as pure shear stress condition. Pure shear stress. Okay, so now we have got the concept, the pure shear stress. Now what happen in case of pure shear stress? Again, enlarge this element here. It looks like this. Okay, something like this, and your stress act like this. Okay, so what are the resultant? Here you can see that here resultant stress or resultant force is acting like this, and in this direction it is acting like this, and here a resultant compressive force is acting, here also a resultant compressive force is acting. So initially each of this angle is pi by 2, okay, and after this stress is being applied, what will happen? Due to this resultant tensile stress, this diagonal will be stretched, okay, let's say up to here and up to here. So this is the new diagonal, and also this diagonal will be compressed, let's say up to here. After compression the diagonal becomes shortened, so this square now has become a rhombus like this, okay, and all the angle has been changed as there is no normal stress, so not any of the side has been changed, only the diagonal has been changed. That's why, let's say this angle was previously pi by 2, now it has become pi by 2 minus any angle, let's say gamma, or this half angle, it was previously pi by 4, now it has become pi by 4 minus gamma by 2, okay. Here this gamma is known as your shear strain, okay. Let visualize this shear strain more clearly. How? Well, let's say this is a rectangle, okay, this is your rectangle. Let name it, this one your A, B, C, this is D, okay. Now you are applying a shear stress like this. Let's say you are applying here the shear stress, this is the base, this is the reaction shear stress, and these are the complementary shear stress. What will happen when you apply this shear stress? This will deform. Let's say A will move up to this point, and this is your A dashed, and B will move up to this point, this is B dashed, okay, and this is your new shape here. What is gamma? This angle is your gamma. How you can find it? Simply tan gamma is your A dash by your this base or height, whatever you call it. If this is gamma, this become base, okay. So tan gamma is height A dash divided by base A D, okay. As gamma is very small, we can say that tan gamma is only gamma, okay, and it is A dash by A D. Clear? So this is your shear strain, and you know, as per Hooke's law, your stress is always proportional to strain. Where here your shear stress is shear stress, that is your tau, and strain is not epsilon, this is gamma. So if we equal this, we have to put a constant, that is tau is equal to, let's say constant is G into gamma, or you can say gamma is equal to tau by G. Here G is known as your modulus of elasticity. You know that modulus of elasticity in shear. Previously for E we called it modulus of elasticity, but here G is modulus of elasticity in shear, and this elasticity in shear is known as your rigidity. So you can say G is modulus of rigidity, okay. Now here previously this was your actual shape, and after applying your shear stress like this, it has been changed into a rhombus or rhomboidal shape, okay. So I can say that the total deformation is a function of this diagonal stretch or enlargement of this diagonal and contraction of this diagonal. Okay, so we can say this deformation can be defined by two things. One is the elongation of this diagonal, okay, and your contraction of this diagonal. Clear? Now you can say that we have already learned how to calculate the elongation of any body when it is under any stress by using modulus of elasticity and Poisson ratio. Okay, that means this deformation can also be calculated by using modulus of elasticity and Poisson's ratio, but just we have learned that this deformation or the shear strain gamma is tau by g. So obviously there is a relation between this g and this E and mu. So what is the relation? You have learned already there is a relation, and why there is a relation, you have got the logic. Now the question is, what is that relation? Okay, so first we will consider again this object like this. Let's say initially this was your body. You have applied stress here, sigma x, here sigma x, and in this direction sigma y, in this direction sigma y. Clear? And let's say this was your axis. Okay, the overall axis in this body was like this, and we have considered a body like this which is under pure shear. Okay, this body is under your pure shear. Let's name it A, B, C, D. Okay, now after application of this pure shear stress, you know what has happened, it has changed its shape. Okay, and now due to this resultant tensile stress, this B has come to B dash, D has come to, let's say initially D was here, now it has come to this point, and due to compressive or resultant compression, A has come down to this point, this is A dash, and C has go up this point, up to this point, this is your C dash. Okay, so if we consider, let's say this was origin, it is O. If we consider triangle OAB only, okay, sorry, OAB. Now what is the changed shape? It has changed like this. Okay, this is the changed shape. So the changed triangle is triangle OA dashed B dashed. Clear? So previously this angle was how much? It was your pi by 4. Now what is this angle? It has been reduced, and the angle is pi by 4 minus gamma by 2, because total change in angle is your gamma. Okay, so now if I ask you what is the value of this tan pi by 4 minus gamma by pi by 4 minus gamma by 2, you can say me this is your height divided by base. Okay, simple geometry. What is height? Height is your OA dashed, base is your this one, the new base, this is your OB dashed. Okay, now what is OA dashed? Well, this is, let's say OA dashed is, we can say this is OA multiplied with 1 plus sigma y. You know how it has come. And for OB dashed, it is OB1 plus sigma, epsilon x in this direction. Okay, for this direction, this is the x direction and this is your y direction. So tan pi by 4 minus gamma by 2 has come down as 1 plus epsilon y by 1 plus epsilon x. Okay, because OA and OB is same. Okay, now our task is we have to find what is epsilon y and what is epsilon x. Okay, you have already considered this body is under pure shear stress. And what is the condition for this pure shear stress? Here sigma x is equal to minus sigma y is equal to tau y. Just recap the stress circle. Here this was your sigma x, this was your sigma y, and the stress acting at this point is tau. This is nothing but your radius or sigma x or minus sigma y. Clear? So what is what is strain in x direction? Sigma epsilon x. Epsilon x is, here I just want to mention, if you don't know how to calculate this strain when there is stress acting in both the mutually perpendicular direction, you can watch my last video or the previous video. Okay, so and if you have already watched it, you know that epsilon x is your sigma x by 2 minus mu times minus sigma y by, don't put the sign, sigma y by E. This is the general equation. Okay, and in this case for pure shear stress, you know sigma x is equal to tau, so put tau by E, and minus sigma y is equal to tau, so here put positive sign and here put tau by E. So it is coming as your tau by E multiplied with 1 plus mu. This is your epsilon x or strain in diagonal dB. Okay, again what is the value of epsilon y? Simply sigma y by E minus mu times sigma x by E. This is general formula, and in our case sigma y is equal to minus tau, so put minus tau by E minus mu times, again sigma x is equal to tau, so put tau instead of sigma x, it is coming as this one, so you can write minus tau by E into 1 plus mu. This is epsilon y. No question? Okay, again go back to this formula. We have to calculate tan pi by 4 minus y by 2. Okay, for your information, tan pi by 4 minus gamma by 2 can be written as tan pi by 4 or 1 minus tan gamma by 2 or only gamma by 2, as gamma is very small, divided by 1 plus tan pi by 4 or 1 multiplied with tan gamma by 2 or gamma by 2. Clear? This is your 11th or 10th standard trigonometry. So now this has come as your, what was our equation? Let's see, this was this one, so let write it down, 1 plus epsilon y by 1 plus epsilon x. Okay, and you have already find out the value of epsilon x and epsilon y. Let put them. So your 1 minus gamma by 2 by 1 plus gamma by 2 is coming as 1 plus epsilon y is minus this one, so remove the positive sign here, minus tau by E into 1 plus mu divided by 1 plus again tau by e 1 plus mu. Okay, so simplify it. Simply we can multiply these two, and this is coming as 1 minus gamma by 2 plus tau by e 1 plus mu minus gamma by 2 into tau by e into 1 plus mu, and at the right side multiply these two. We are getting 1 plus gamma by 2 minus tau by e into 1 plus mu minus gamma by 2 tau by e into 1 plus mu, and here you can cancel out these two, also the 1 from both sides, and here bring the gamma by 2, so you are getting gamma by 2 plus gamma by 2, and in this side bring this one, you are getting 2 tau by e 1 plus mu. So simply we are getting 2 tau by e 1 plus mu is equal to gamma simply, and also here gamma is equal to how much? Gamma is equal to coming as your tau by g. Okay, so replace it, tau by g, and again cancel out tau from both sides. You are getting 2 times 1 plus mu by e is equal to 1 by g, or you are getting that e is equal to you 2 times g 1 plus mu. Okay, am I right? No, I think I made some mistake. Okay, so what is the problem? No, there is no problem, and we can write that g is equal to e by 2 1 plus mu. So this is right and this is also right. So we have established the relation between E, G and mu. Okay, so in this video we have learned what is pure shear stress and how to find the deformation in case of pure shear stress, and more importantly what is the mutual relation between this modulus of elasticity, modulus of rigidity and your Poisson ratio. Okay, so if till now you have not subscribed this channel, please do it to get more videos like this in upcoming days.